On my workbench today is this Yamaha CA610 2 II. It's not powering on. I haven't powered it on yet. I'm not going to power it on until I open it up and inspect the inside, the complete inside. One thing I did notice right off the bat is the RCA jacks, I don't know if the camera can pick it up, are incredibly oxidized. I mean, every single one of them feels like sandpaper. So that doesn't bode well for the potentiometers and the switches that are inside this unit. Even these plugs could be oxidized. So, and the speaker terminals obviously could be oxidized. So I'm going to have to do some major cleaning of this thing before I even power it on. So I'm going to do all that and get back to you. I'm going to do a quick check of the main transistors. First off, right off the bat, I look for shorts. So you got you got 4 output transistors, and I just go from the base to the emitter and to the collector, and just make sure there's no shorts. I hit my tabs together just to make sure, my probes together just to make sure they're working properly. But all 4 transistors are healthy. Next thing I'll do is a diode check of the transistors. And let's see, this is a NPN, it looks like. It's going to be NPN, yep. Base to emitter, base to collector is all good. So this is going to be a PNP, most likely. Yep. And base to emitter, base to collector, all good. And then reverse them back again. This will be an NPN again. All good. And then this one's a PNP again. So that's they all read beautiful. So all 4 power transistors are in healthy condition, which is fantastic. It's probably it's the number one thing that anybody wants to see, is because those are one of the more costly parts, and you have to special order those typically. So the next thing I want to do is just check the power supply here. So I still have the unit unplugged, so just want to check. Let me get the camera down there. It's going to be right in that area there. I think that focuses in on. So I'm going back to the continuity. Across my probes, they're good. This 1 amp 250 volt fuse is good. This fuse, which is hard to read, this is the main fuse, a 5 amp 125 volt. That fuse is blown. Oh yeah, I can see a burn mark on the fuse. So I'm going to go ahead and pull that out. And get in there. There we go. Yeah, she's burnt pretty good. Alright, and then next thing I do is to kind of go down the line here. I'm going to check the diodes here. Go back to diode check again. and these should come up to 0.5 volts, and you'll get some leakage or some charging of the capacitors maybe. So, and check this one. Hope if I can get my probes on there. There we go. Come on, get on there. Okay, there it goes. Yep, it's coming up to 0.5, and there it is, 0.5. Let me see if the camera's picking that up. Oh, no, the camera's not picking that up. Sorry about that. Okay, let me move this over, although I don't know if the fluorescent light above me is going to even give you a good view of that or not. Actually, here, if I can bring that a little bit back. Yeah, there we go. And then let's check these guys out on the back here. Ew. Nope, I'm not getting 0.5 on that one. That one looks like a direct short right off the bat. Let me go the reverse direction on here. Yeah. That one looks like a shorted diode. Let me go to this back one here. And, ooh, same thing. Yep, same thing. So those two diodes seem to be shorted. These two seem to be healthy, though I will double check those once I get underneath this board. So that's what I'm going to do right now, is I'm going to open up the bottom of the chassis, and I'll pull one leg up on each of these diodes and then retest them. And that's the best way to do that. So I desoldered the outside of the outside legs of these, so I can pop them up here, and that way I can test them without interfering with each other. If I can gently do this. There we go. That's those two. Here, I guess I should turn on my light, shouldn't I? There we go. And then same with these other ones over here. I'm going to pull up those. Not a lot of room to work here. There we go. And last one there. There, that one is popped up. Okay, so they're all up for a test. So here I tap my things together here, my probes together. And then if I can get in there, not a lot of room to work here, but I'll see if I can do it. Oh, man, I can't even tell if I'm hitting what I'm supposed to be hitting here. Kind of tweak it around here a little bit. Jeez. It's in the where I'm trying to hit is being blocked. I'm blocking my own light. Okay, so that one's good. I think, you know what I should do is I'll do a diode test on this one right away too. Make sure I am on it. Yeah, I believe I am on it there. So let me reverse these, do a diode test. Yep, that one's beautiful. Do the same thing with this one. Perfect, getting to 0.5, and it should not be going in this direction, which it's not. This one, same thing. Oh, I'm getting 0.5 there now. Okay. So something else is amiss there. Oh, there's my problem. Yep, that diode is shorted. So let me go back to continuity here. Continuity in that direction. Continuity in that direction. So that diode is direct short. The other diodes are healthy. Okay. Now, what I usually do at this point is I can do this while the camera's still running here, I think. Let me turn this monster upside down here and re-angle the camera. Okay, here we go. And I'll zoom in. Okay, so that is the area that I desoldered. And so this spot right here, you can see in this spot right here is where I desoldered the diodes on the one side. And then what I want to do now is just do another continuity test. Make sure that there's nothing in the circuit now that is shorted here. That beep is simply because the capacitor is charging from my probes. It takes a while. These are big capacitors, so it takes them a while to charge up. All is good. I'm not getting any type of direct short there, so that's great. So in other words, even if I was to put a healthy diode back in here, I wouldn't want there to be a short that would simply short the diode back out again. So that's all good. So here's the 4 rectifier diodes that I just pulled out. This one, if you can hear that over our sump pump running in the background, that one's a dead short. These 3, while they don't test bad, they test good. I'm still going to replace all of these because it's my assumption that the manufacturer underestimated the overall amperage rating needed for this receiver. So I'm just going to replace them all with a slightly higher quality diode. Okay, so now I replaced all 4 diodes. I'll zoom in here and let you see them. There's the 4 that there we go. There is the 4 that I replaced. Once again I put those guards on each of the legs of the diodes. Normally that is heat shrink that I put around, but I did not shrink the tubing down because you want those to breathe to allow heat to escape. So with that said, I'm going to now, the transistor that blew out, or the fuse that blew out, I'm going to replace with a, let's go with a, I'll try 0.5 amp. Actually no, the inrush current. The inrush current is going to charge the caps is going to be quite a bit, so I think I'll go with a 2 amp fuse. See how that goes. Be right back. I'm going ahead and power on now. So here's my dim bulb tester over here. I'm going to start out on a 40 watt and see what'll normally happen is when you turn on an amplifier, especially a big amp like this, the inrush current to charge the filter caps will cause that bulb to come up to pretty good brightness, and then it should dim back down. Now it may not dim back down fully to to not being able to see it. It all depends on just how much power this thing consumes on idle. So let's just see what happens here when I power it on. Beautiful. That's exactly what's supposed to happen. That means so far we have a healthy amplifier, and even better yet, I just heard the protection circuit kick in. So that's all good. So I'm going to do a couple more tests in just a bit here. I'll get back to you in a bit. Another thing I figure I should mention is that relay right there is for the protection circuit. If the receiver is unhealthy, it will stay kicked out. I heard it kick in, so that's a good sign. What I also tend to do though is I always look at the relay. I try to use a bright light to shine in there, because the best thing to do on any large amplifier receiver is to always turn the volume control all the way down when you turn the receiver off, so that way when you turn the receiver back on, the volume is down and it's not causing any extra inrush current. So to keep that relay healthy, always turn the volume control all the way down. Turn the receiver on and off. Alright, the next test I want to do is to test with nothing hooked up to the amplifier and the volume control all the way down and pretty much all of the switches in what I would call a neutral state. In other words, you know, nothing input, bass and treble all set to 0, speaker switch. Just speaker switch obviously needs to be turned on because that's what I'm about to test. And I usually keep the input selector at auxiliary, which it is. So now what I want to do here, if I can read this at the same time you're reading it, let's see if that's possible. Yeah, it looks good. Okay, let's test for what the volts are out on these terminals. 6 millivolts or 5 millivolts. That's beautiful. That's exactly what I would want to see. Anywhere from 0 millivolts up to about no less than, or no more than typically 50 millivolts. Even I've seen amps, some amps or receivers actually can go up even higher than that, but never ever over 100 millivolts. That can damage speakers pretty quickly. So this is beautiful. I'm getting 5 to 6 millivolts on each of these. That's beautiful. That one's, yeah, it's kind of floating around a little bit, but yeah, a little bit of oxidation on these terminals too. So that's a beautiful sign. Okay, maybe you can hear. I've got it playing. I've got, I put my cell phone connected to aux in. I've got 2 tiny speakers up here that are up above me that I use for my testing. A little bit of Steve Winwood playing. Okay, so everything seems healthy. See nothing unusual going on here. So next up is to bring the oscilloscope out and let's do and my dummy load for the speaker output, and let's do a load test on this thing. And before I do a load test, I have to replace that fuse with the proper fuse. Before I bring out my oscilloscope, I'm going to do one more test. I've got my dummy load set up right now. 8 ohm resistors going into both speaker jacks here. I've got my cell phone with a dual equal sine wave outputting from it to the aux in. Stereo is on, sitting at idle right now. I want to see if I can get that 40 watt bulb to light up a little bit. I'm not real familiar with the controls on here, so let's just see what happens here. I don't even know what the wattage rating of this. I didn't even turn the light off here first. Oh, yep, see you there. So the light is on right now already, and that's just at idle. See how it's getting a little bit brighter as I go up with the volume there? They go a lot brighter now, simply because it's drawing from it. So what I'm going to do is I'm going to bring in the 60 watt bulb. So now I've got 100 watts available for the receiver, for the amplifier. And let's do the same thing. I'm going to turn off the light here. Let's see if we can get those bulbs to light up at all. And I've got the, I've only got the volume at number 4 right now. And so it's coming up to number 5 now, and they're just starting to come on now. Those bulbs are just starting to come on. So that's a good sign. Everything is healthy. That means all is good. That's exactly what's supposed to happen. What I can do also, let me turn this off for a second. See if there's a power rating on the back of this beast. Some places are real good at it, other ones not so good. Yeah, okay. This tells me everything. 300 watts. I'm assuming that might be maximum. 300 watts might be the maximum output. I highly doubt that's the idle. The idle is probably only at about 20, 25 watts. So yeah, I'm guessing that's the maximum wattage that this thing would consume. So as I said, that's 100 watts available there. I could bring in the other 100 watt bulb in there, so that would be 200 watts coming in, but there's no reason to. I just wanted to make sure that there wasn't a direct short or anything that seemed to be shorting once I turned up the volume control. Since that tested great, I'll be back in a bit. I'll get the oscilloscope. Okay, I forgot to turn my camcorder on earlier. I had the amplifier upside down, and I found about 4 or 5 solder joints. I looked across the entire circuit board, which are quite a few thousand solder joints, probably 1,000 or 2,000 at least, I would think. But I found 4 or 5 that were questionable, and the reason I mainly did that was because when I did, I had the oscilloscope on, I noticed that one channel, the waveform wasn't quite right. So that's what alerted me to maybe that there could be a loose solder joint, or either that or another component that has a problem. But I repaired the solder joints, and now I get a great waveform. So what I'm about to do is a load test on the amp. So I got the oscilloscope set up, I've got the speaker outputs going to 8 ohm dummy loads over here, and I've got my cell phone outputting a sine wave onto each channel at 1000 kilohertz. So we're ready to go here. It's not a big deal here. So I've had the amplifier warming up, by the way, for a while now, because that's a good thing to do, I would say, with any load test like this. So here we go. I mean, it's a pretty easy thing. I'm just going to turn up the volume. And I have, by the way, I do have our power now on the mains. I don't have it on my dim bulb tester anymore either. So here we go. I'll bring the camera over so you can see the sine wave a little bit better here. And there's going to be a lot of noise on the sine waves right now because of the way I've got the wiring here. It's kind of a disaster over here. So sine waves are coming up at some point. Yeah, there you go. Now they come up clear. And let me bring the camera over there so that I can show you what's going on. Closer view. Okay, so here we are. And I'm going to just keep turning up the volume until we get to clipping, which is a slight flat spot on the sine wave. And getting close. And still cramming. Okay, there's a sine wave. There's a clipping. See if the blue wave is clipping. You see it ever so slightly, it's clipping. So let's go back just before clipping, which is right there, I would say. And we're at 20.8. Let's just say 21 volts. Okay. And that is the RMS value of that sine wave. So let me turn it back down because I'm really pushing the amp right now. Let me turn all the way back down to nothing. And let's do a quick calculation of what that means. Okay, if I can do this without the camera falling off of my chair here. I just got it propping on a padded chair here. Okay, let's see here. Okay, calculation. Turn it on. So 21 volts times 21 equals 441 divided by 8 equals 55 watts per channel. Now, I think I told Rich that I was up to 61 watts or something like that. That's because I think I was pushing it into clipping. So this time I was more careful on the keeping it just below clipping. So we're at 55 watts. I think this thing's rated for 50 watts per channel, so that's a good sign that manufacturer, it's got plenty of power into 8 ohms anyway, so all is good. Kind of a bummer of a note as far as the design of this Yamaha goes is how sad this heatsink is. It's just an absolutely ridiculous design as far as just to put just a piece of sheet steel like this with, you know, no, in modern amplifiers, they have a much higher quality heatsink. They do a very thin flaps. It looks like something aerodynamic more or less than anything, but it's got, you know, a modern amp has like 20 to 50 little wings that come off of these. This is just pretty sad that they just put a big chunk of aluminum in here. And what's even worse is that if you look down here, there's no air vents below this thing on this side. I mean, there should be it should be completely, you know, air coming up on both sides of this thing to keep these power transistors that are on this side cool. They do have, as you can see, holes in because this is an L-shaped piece of aluminum, they do have holes in it, but that's even asinine. It's just really, really a pathetic, just a pathetic design. It's like somebody, whoever did this is absolutely clueless as to, you know, how to properly cool transistor. Because if you were to crank this thing for hours on end, you know, you're just damaging these power transistors. It's like, you know, heat is one of the biggest enemies to electronics next to moisture. So, and one last thing I already did before I close this amplifier up is I doubled. See this? If I can see it pointed down there, right there. There is a transistor mounted to this small aluminum heatsink. Well, every manufacturer I've ever seen, I think, with these older amplifiers and stereo receivers, that's one of the most important transistors in the voltage regulation as the power comes through the power supply here. And they always underestimate. They always put a small heatsink on these things, and they always run super hot, which this one was doing. Well, not super hot, but hot, without a doubt. So what I did was I added twice the size of a piece of aluminum I bolted it right to the original heatsink, and I also added hot glue at the bottom and on each side, which the manufacturer failed to do. So this thing was wobbling like crazy. So every vibration that this amplifier had to deal with, this thing, the solder joints would have broken loose over time, depending on how often you're moving your amp around. So anyway, it's really solid in place now. So, and it'll be just that much happier. So that's it. Well, it is what it is. I am done with this. It's working great. So that's all I'm going to do to it.